Hello, Honors Algebra 2. Today we are doing a brief summary and then we will continue reviewing for your Unit 2 test tomorrow. So up at the top here, we just have a bunch of definitions of words we've been using throughout this unit. Zero, root, solution, and x-intercept. All of these are the same exact thing. And then a factor, we say that x minus k, which is a zero, root, or solution, is a factor of our polynomial, and that's because it can be divided out evenly. So something we haven't mentioned, but you may have noticed, is the turning points of a polynomial function, otherwise known as the mins and max. This up here, for example, this graph that I have on my calculator, which you will be using in this first example down here, this is a cubic function. It's an x to the third power. You can tell because of the way that it swoops here. So something interesting that occurs is based on the degree, and remember that's the highest exponent, so in this case it's a 3, it has at most n minus 1 turning points, or mins or maxes. So 3 minus 1 is 2. That means that if you have something that has an exponent of 3, the most mins or total maxes it can have is 2. And you can notice it does have 1 min, 1 max, so 2 total. And if a polynomial function has n distinct real zeros, so not imaginary but real, then it has exactly n minus 1 turning point. So this has 3 real zeros, 1, 2, 3, because it has 3 intersection points. And because of that, because the number of real zeros matches the degree, it means that you have 2 total turning points, 2 mins and maxes total. So in this case, 1 of each. So that's just something to notice. It's not something you're going to be tested on, but it does kind of give you an idea of what your graph should look like based on the degree. It kind of tells you whether you need to make your window bigger or smaller so you can see everything going on in the graph. So all right, let's move on to this. You want to make a rectangular box that is x centimeters high, x plus 5 centimeters long, and 10 minus x centimeters wide. What is the greatest volume possible? What will the dimensions of the box be? All right, so what you should remember is that volume, we're going to make this a little easier to read. Volume is length times width times height. So our volume, and I'm going to write that as v of x, is x times x plus 5 times 10 minus x. Now, if you want to FOIL this out, you certainly can, but I mean, your calculator is going to do all the work for you. So I'm just going to type it in like that. In fact, that's what I've already done. We are looking for the greatest volume possible. That means we're looking for our max. All right, so you can pause the video for a second, go ahead, get it typed in. You're going to notice that your graph doesn't look like this immediately based on your window. I did want to show you though the cubic form, the way the graph looks. Now if you think about it, x can't be negative in this case. So all of this over here we don't really care about, because if x is negative then this box is negative centimeters high, which doesn't really make sense. So your window, I'm going to change my x to 0, and then since we're looking for the max, I just changed my max to a bigger number until I could actually see the top of my graph. Okay. So all right, so here's the picture. Again, go ahead and pause and get this typed in if you need to. I'm just going to keep going. And you've got something like this. We are looking for the max. And we've got my slow calculator. Okay. All right, so your max should be a 6.0. It does say to round to the nearest tenth, so that's going to be 6.1, comma 264.1. So your x coordinate is 6.1. That's referring to how high the box is. Your y coordinate is your volume, so this would be the max volume. And that would be 264.1 centimeters cube, or cubic centimeters. Your height is 6.1 centimeters. And then we're just going to plug 6.1 in to each of your other expressions to figure out the length and the width. So x plus 5, which will be your length, 6.1 plus 5 is 11.1. And 10 minus 6.1 is 3.9. So that's how wide it is. So your dimensions are 6.1 by 11.1 by 3.9. And there you go. And you might have a similar problem on your extra credit on your test. Nudge, nudge, wink, wink. All right, so there you go. Let's flip to the back. I'm going to pause the video for a second to go ahead and get this next equation typed into my calculator, because you know I always like to graph this first. Even though it says part C, sketch the graph, we're always going to do that first. So I'm going to go ahead and pause the video. You go ahead and pause the video and get this typed into your calculator, and we'll meet back in just a minute. All right, so I'm back. So here's my graph. Your window might look a little different. That's okay. It doesn't matter as long as you can see all of your maxes and mins. And you should notice that you have 3 x-intercepts, 1, 2, 3. You have 1 max and you have 1 min. So I want you to notice before we pause again so you can actually graph this, is that this polynomial function is already factored a little bit. The x squared plus 9 has been factored out of this part, but if you were to FOIL it, which I don't want you to do, but if you were to FOIL it, you would end up with an x to the 5th. So remember, this degree tells you how many total zeros you have. We can see we have 3 real on our graph because of your 3 x-intercepts, but that means that there have to be 2 more, and that means those are going to be imaginary. Okay, so just something to keep in mind when we do get down to our final answer, find all zeros for part B, you are going to have 5 total. Okay, all right, so I'm going to have you pause the video again. I want you to find all of your mins and maxes and all intercepts, and then we'll check our answers for that, and then we'll go ahead and continue the problem. All right, go ahead and pause it. All right, so I'm back. So this is what my graph looks like. Hopefully we agree on our rounding. I do want to point out that this graph really only has one rational solution that you're going to be able to identify, which is the 1. So when we get to part A, factor completely, the 1 is really the only thing that we can use for our synthetic division. Now keep in mind that if you had a bunch of rational solutions, if you had a 2, if you had a 1/2, you could start with whichever one of those you want, but the 1 is really the only thing we have. Now when we factor this 1 out, the x squared plus 9 is already taken care of. So the only thing that you need to use with your synthetic division is this cubic part here, this first part of the polynomial. We're not going to use the other part because it's already been factored out. Just make sure you don't forget any parts. You have cube squared x1. Okay, so that's everything. Let's go ahead and do our synthetic division. 1 times 1 is 1. Remember, you are adding. 3 times 1 is 3. Adding, and remember you want this to be a 0. If it isn't, it means you messed up, because we know that 1 is a solution. That means your remainder should be 0. This comes down to x squared plus 3x minus 1. Now this is not going to be able to be factored. As you can tell, there are no numbers that multiply to -1 and add to 3, so we can just write our factored form. Don't forget about the x minus 1. It does need to be a negative, because when you do zero product property, that's how you're going to get positive as your answer. X squared plus 3x minus 1, and then you have the x squared plus 9 that was there originally. All right, that's your factored form. Next, part B, find all zeros. 1 you already know. X equals 1. This guy, you can't factor it. guess what you're going to have to do? Quadratic formula. X is equal to opposite b plus or minus square root. B squared is 9 minus 4ac all over 2a. Okay, go ahead and evaluate your discriminant. That's going to be 9 plus 4, which is 13. 13 you can't do a factor tree with, and even if you split your fraction, nothing's going to reduce, so this is fine. Keep in mind this is 2 of your answers. This is actually representing the negative 3.03 and the 0.303. If you type this into your calculator and rounded it, you would get those. Here's your other real solution, and then don't forget about your imaginaries. That's going to be these guys here. X squared plus 9 equals 0. Subtract over your 9. When you square root both sides, you'll get x equals plus or minus 3i. So remember 5 total solutions, 1, 2, 3, and sorry, it looked like the 2 was one of them. 2, 3 meaning the plus and the minus, and 4, 5, the plus and the minus. All right. Last thing, describe the end behavior of the function. That's actually part D. So end behavior, remember, starts as x approaches positive infinity and as x approaches negative infinity. Feel free to not use the plus. F of x approaches. So as we go to the right, your graph is going up. So as x approaches positive infinity, f of x also approaches positive infinity. And as we go to the left, the arrow is going down. So as x approaches negative infinity, f of x also approaches negative infinity. All right, there you go. So I will be back tomorrow. We can review again and actually go over your quizzes instead of you just seeing them. Your homework tonight is worksheet 9. However, if you want, you can also start the review. And you should notice in your packet, there's also a Unit 2 extra review. They are both just one side, or like one sheet, front and back each. So you're welcome to work on any of those 3 worksheets tonight, and we'll go over questions tomorrow. All right, I hope you have a great night. Bye.